Good morning, students. So, on the last turn, we studied about work. What are the cases in which work is done? When is work maximum? That is, angle between force and displacement is 0. That means both are in the same direction. Then it is the maximum work done. And when force and displacement are perpendicular to each other, no work is done. So we all studied this. Now we are going to study another part of the chapter, which is power. So we are going to study power. So we move to the next. Now what is power? Whose power? Power of an agent doing work. I am doing work, so I will have some power. Then only I am able to do some work. Now my scooty. Suppose I am driving my scooty. So in that case, my scooty is doing work. My scooty is taking the load of me and doing a displacement. So my scooty has a power to do the work. Okay? So, what is power? Power is an agent doing work. Anything, any machine doing work. All the machines will have some power and then only they will be able to do some work. So, what is power? Power is the capacity to do work. The rate of doing work will be power. So now, suppose here the first one is saying I pulled 2 Newton for 8 meter in 4 seconds. Okay. So what will be the work? Work will be 2 Newton into 8 meters. And what will be the work done in 1 second? 64 joules. And in the next case, I pulled 3 Newtons for 4 meter in 7 seconds. So 3 Newton into 4 meter is 12 Newton meter. And 12 Newton meter into 7 because I am taking out the work done in 1 second. So 4 Newton into 3 meter is 12. 12 into 7 is 84. So work done here is 84 joules in 1 second. Now I pulled 3 Newton for 9 meters in 6 seconds. So how much work done in 1 second? 9 meter into 3 Newton, that makes it 27 Newton meter into 6, that is 135 joules. Now, who is doing the maximum work in 1 second? 135 joules, isn't it? So, that body is having the maximum power. That body can do 135 joules of work in 1 second. Okay, so this way we compare power. So we move to the next one. So in this way we conclude that the machine which is doing the maximum work in 1 second is the machine having the maximum power. So what is it? Rate of doing work. Isn't it? Now, if I take 10 machines, there are 10 machines and I see that which machine is doing the maximum work in a second. Now, that machine will have the maximum power. That machine is having the maximum efficiency of doing work. That machine can do the most of the work in 1 second. And so that machine is having the maximum power. So what will be power here now? It will be the rate of doing work. It will be the rate of doing work. Now, power is the rate of transfer of energy or the rate at which work gets done. Okay. Now we can see here, this man is running upstairs. Now, he is doing work. In what way? mgh. Force is in the form of mg, that is mass into acceleration due to gravity, and he is moving upstairs, so displacement is in terms of height. Okay, so the work done is in the terms of mgh, and the time taken in moving from the ground to upstairs, that will be noted, and this will be the power of this person doing work. Okay, so power is equal to work upon time. The units we will discuss later. So you must have understood till now what is power. So we go to the next one. So we studied that power is rate of doing work. So suppose in t seconds, W work is done. So in 1 second, W by T work will be done. And that is the power of that body. Now, as power is equal to W by T, so we can write W is equal to P into T. Isn't it? We cross multiply, W is equal to P into T. Now, energy consumed, this is energy consumed only, no? So, energy will be power of the machine into time. So, from this, what we say, work is what? When somebody is doing work, that means energy is being applied over there. Energy is there. So what will be the energy? Power of the machine into the time. Power of the machine multiplied by the time will be the energy. Example, one bulb of 100 watts. You go and purchase bulb and you say, please give me 100 watt bulb. So one bulb of 100 watts glows for 50 seconds. Okay. So what is the energy consumed? What is the power consumed? What is the energy consumed over here? Energy consumed will be 100 watts into 50 seconds, and that comes to 5,000 joules. Okay. So we move to the next one. Now students, it will be better if you take a notebook and a pen and sit. Now we already spoke about this, that power is equal to work upon time. And we have studied that work is equal to force into displacement. Now force into displacement upon time, and force into displacement upon time. Displacement upon time is what? Velocity. So power is equal to force into displacement upon time, and so the formula changes to power is equal to force into velocity. Now this is the another form of this same formula which will be applied in these questions here. So you have to remember this also. One is power is equal to work upon time. That means rate of doing work is power. And one more, power is force into velocity. Okay. Now you must have known from where is it coming. We have already studied work. We know what is time. So force into displacement upon time, and so it comes as power is equal to force into velocity. So we move to the next one. So power is equal to work upon time, and power is equal to force into velocity. Now one example on the same. A train is running with an engine. The engine is applying force of 1000 Newton. The speed of the train is 20 meters per second. What will be the power? Power is equal to force into velocity. So force here given is 1000 Newton, velocity is 20 meter per second, and when we multiply, we get 20,000 watts. Okay? So simple. We don't have to look here and there with anything. Power is equal to force into velocity. Okay? Thus, power spent by a source depends on two factors. What is it? The amount of work done by the source. It can be anything. It can be our own body also. So amount of work done by the source. And number two, the time taken by the source to do the given work. Okay. Now, there are some units for power. The first one, which I am speaking from a long time here, 1 watt is equal to 1 joule per second. Now work is in joules, time is in second. So 1 joule upon 1 second is 1 watt. Okay, and this is the unit of power. We always write, this is a normal unit of power which we usually use. Okay, so 1 watt is equal to 1 joule per 1 second. Okay, so when 1 joule of work is done in 1 second, then we say that the body possesses the power of 1 watt. Okay. Now, there is one more unit of power which is known as horsepower. Must have heard. This is a bigger unit of power, and the value is 1 horsepower is equal to 746 watts or 0.746 kilowatts. Okay. There are some more bigger units, but we will talk about it later. Okay. So we move to the next one. So now here we are going to do energy. Energy as work done. I had spoken in one of the statements earlier that work done is energy. So here, energy as work done. Okay. The body which is capable of doing work is said to possess some energy. And this energy possessed by the body is measured by the amount of work that the body can do. When a body does work, its energy decreases. Now, I have some energy. I start doing some work. Obviously, my energy will decrease. While if work is done on the body, its energy increases. If somebody else does the work on me, then my energy will increase. This means that there is always a transfer of energy when work is done. Thus, energy and work are related to each other. And how are they related? The energy of a body is its capacity to do work. What is my capacity to do work is my energy. Please try to understand. Rate of doing work is power. Capacity of doing work is energy. Power is whatever work is done in unit time is power. Whereas what amount of work I can do, what is my efficiency of doing work is my energy. So the things are little bit different at some point. So what is it? The energy of a body is its capacity to do work. Okay. Now, like work, energy is also a scalar quantity. Okay. There are some units of energy. SI unit of energy is joule. And CGS unit is erg, the same as work. 1 joule is equal to 10 to the power 7 ergs. We have already studied. 1 watt hour. This is a bigger unit of energy. 1 watt hour. And what is that? 1 joule per second into 3600 seconds. That comes to 3600 joules, which is 3.6 kilojoules. Okay? You have studied pico, nano, micro, milli, centi, deci, deca, hecto, kilo, myria, mega, zega, tera. I hope you have studied these prefixes in class 9. There was a list of prefixes, and those prefixes had some value. When we put these prefixes before a unit, this gives a value to the unit. Suppose I write kilometer, that means 10 to the power 3 meters. If I write millimeter, that means 10 to the power minus 3 meters, isn't it? So, the same way, these prefixes are important. You have already studied about it. So, please do remember in the conversion of units. Now, 1 calorie is equal to 4.18 joules, which is equal to 4.2 joules approximately. So, this is a different unit of energy. And 1 electron volt, which is equal to 1.6 into 10 to the power minus 19 joules. And what is 1 electron? 1 electron volt is the energy gained by an electron when it is accelerated through a potential difference of 1 volt. Okay? So these are some units of energy. Calorie, heat energy is usually measured in calories. 1 calorie is the energy required in raising the temperature of 1 gram of water through 1 degree Celsius. Okay. So these are few units of energy. So we will be using these units in some of the numericals. So we move to the other one.
Here, energy is equal to power into time. Please remember this. Here, energy is equal to power into time, whereas power is equal to work upon time. So, you have to relate things properly. Okay, so we move to the next one.
Yeah. So, students, before moving to this numerical, I just want to mention one more thing. Suppose I have a machine, suppose pump, okay, and the power of the pump is 30 watts, suppose, okay. Now, the power will lift water, it will take to some higher place. Now, while lifting water, when we noted, now the work done is only 20 joules per second. We had 30 watt and now the work done is only 20 joules per second. That means 20 watts. So, where has this power gone? This power has been used up because the machine is not fully efficient. So, this power, this energy has dissipated in form of any other energy, in form of heat, in form of any other thing. So a machine is not fully efficient. Okay. Some part of the energy will be unuseful energy. All the energy will not be used in machines. Okay. So we come back to the numerical. A boy weighing 350 Newton climbs up 30 steps, each 20 centimeter high, in 1 minute. Calculate the work done and power spent. Now, work done is force into displacement, and force will be taken as mg, and D will be H here. So the work done will be in the form of mgh. Now, it has been given that force is 350 Newton. So mg is given as 350 Newton. How many steps are there? 30. So we have to take the height, no? So 30 into one step is of 20 centimeters. So 30 into 20. And that is centimeter. So we will convert it to meter. So upon 100. So work done is 2100 joules. Now power spent, work upon time. So 2100 joules upon 60 seconds, and that gives 35 watt. Okay? Numericals are very easy. So we go to the next one. So now here we have another numerical. A boy takes 3 minutes to lift a 20-liter water bucket from a 20-meter deep well, while his father does it in 2 minutes. Part A of the question, compare work done and power developed by them. And B, how much work each does. Take density of water as 10 to the power 3 kg per meter cube and G as 9.8 Newton per kg. Okay? Now, let us understand the question first. If the question is understood, it is half done. So, there is a boy who is doing some work in 3 minutes. And what is the work? To lift 20 liter of water from a well which is 20 meter deep. And the same work is done by the father. And he is doing only in 2 minutes. So, father has more power. Now, we have to calculate work done and power developed by them. We have to compare the work done by them and power developed by them. Okay. So, let us calculate the work done first. The work done is same in both the cases. So, we are calculating the work done. Now, work done here will be again mgh, where m is density into volume. You have studied this. I should not go into the details of density into volume. So mass will be density into volume. So density into volume into acceleration due to gravity into height. This will give me the work done. So density is given as 1000 kg per meter cube. Now volume, it is given 20 liters. So 20 into 1000, it will convert to centimeter cube. If you know 1 liter is equal to 1000 centimeter cube. So 20 into 1000, and to convert centimeter cube to meter cube, I have divided by 1 and 6 zeros. Can you see that? So it is converted to meter cube. So 1000 kg per meter cube into 20 into 1000 meter cube upon 1 and 6 zeros into 9.8 Newton per kg into 20 meters. Now if you see the units, kg and kg will be cancelled, meter cube and meter cube will be cancelled, and we will have Newton meter, and that is the work done. Now, while calculating, we get 20 into 20 into 9.8, which comes to 3920 Newton meter or joules. Now 3920 joules will be written as 3.920 kilojoules, because we can write 3.920 into 1000, and 1000 is what? Kilo. So 3.920 kilojoules. Now, what will be the ratio of the work done? 1:1, because both are doing the same work. What will be the ratio of the power developed by them? The ratio of the power developed by them will be work done upon time. Now work done is same, time is different. So time is given here in minutes, we will take it in seconds. So 3920 divided by 180, 3 minutes converted to seconds will be 180, and 3920 divided by 120, these will be the power of the boy and the man. And when we divide this, we will get the ratio of the power. So 3920 divided by 80 is the power of boy. 3920 divided by 120 is the power of the man. And when these two are divided, we get the ratio of power as 2:3. So the first answer, work done 1:1, power developed by them 2:3. How much work each does? 3920 joules or 3.920 kilojoules. Okay. So this is the numerical. The same way you will get some numericals. I'll give you in homework. Try to do the numericals on your own. If you have any problem, the smallest problem, you please ask me in the comments below. Please do ask. Don't hesitate in asking. Please ask. I'm here to help you out. Try to do the things on your own. You will feel better. You will start liking the subject. The more interest you take, the more better you feel. Physics is very interesting. Try to learn, children. Okay? So, till then, take care. Bye-bye. Please ask me. Again, I'm mentioning, please ask your problems. Numericals, you may face some problems. Please do ask me where, what, I will explain then and there. Okay? Thank you so much for cooperating with me. Okay, take care. Bye-bye.